welcome Natural Resources class. Here we go, video lecture number 1. Been a couple years since I've done this, so I'll probably screw up a time or two, but we'll give it a go. So of course this is Wednesday, it's class for Wednesday. There's also not class on Friday. Honestly, I was going to be gone anyway. I'll probably do a video lecture anyway, so this just makes that part easier. So I'll be working on your quizzes, get them back. I will return them into your POs whenever I can get back to Bethel. Tomorrow sounds like it's going to be kind of nasty, so we'll see. I'll do as best I can on that. So here we go. So we've been dealing with Firescience, and last time I kind of got wound up and got going, gave you a whole extra 3 minutes of class. But I think we left off talking about hydrographs and what can happen before and after a logging job, and this was one. Did I use this one or did I use? Yeah, I used this one. Before and after this is before and after urbanization, but you could superimpose over that set of urbanization logging. That before logging you would have this flattened hydrograph, where after a rainfall event, which is right here, you would have sort of a gradual increase in stream flow that was affected by that rainfall event, as canopy sort of gradually gave water up to stream flow, and it worked its way through the soil to the stream. But you take away the canopy, and if you have a rainfall event, boom, the stream flow of the neighboring stream goes up much more rapidly. Notice the response is much closer to the rainfall event than here before you logged it, and it goes up higher, but then it falls off lower. So this was a big deal back in the day when they were slicking off big areas of pine, because if you think about it, what were they going to do with it? They were floating that downstream to a river, to a mill, down a river to a mill, and that mill, at least initially, was dependent on stream flow to saw the wood, stream flow for power to turn the saw to saw the lumber. And so it kind of worked against itself here. So you might not have enough water for part of the year to even float logs down, or you might have more log jams. And then when you did get them to the mill might have had minimal flow to turn the saw, interspersed by dramatic moments of incredibly high water flow. So I'm kind of characterizing this in a negative sense, and it's not always negative. There are large areas of the West that will log big areas of watersheds. A watershed is an area of the Earth's surface that feeds into one stream. And so they'll log big areas of a watershed just to do this. They want the maximum amount of water from a rainfall event to get into a stream with the hopes of filling a reservoir that people are dependent on for water, irrigation, power, whatever. So I characterize it negatively, and that's not always the case. Certainly in the original pine logging era days, it was definitely more negative than positive, and they just weren't thinking about those sort of effects. Maybe they didn't even care about them. Didn't see a connection, maybe, but maybe they did too. So it's not all roses for sure. So they had the fire issue, they have the stream flow issue, and now if we go to other considerations. So this is new stuff right here. Soils. The type of soil will affect or be affected by fire differently. Organic soil. So when I say organic soil, what do you suppose I mean? Well, this is from down by Cannon Falls, Minnesota, just south of the cities here. This is dark, rich soil. I mean, this is really top shelf farmland. And this has a high organic component in it. It's organics from plant residues left over from agriculture and previously. And really, we'll talk more about soils when we get to agriculture. We have the plant remains there that are, at least their decay is drastically slowed down or even stopped sometimes, because you want that material in the ground for lots of reasons, to hold water, to provide nutrients, things of that sort. Problem is, if this dries out, it can burn. So as far as stopping a fire, you want to have soil more typical of northern Minnesota, which is this stuff. Rocks, gravels, sand-sized stuff. This soil is almost entirely made up of pieces or whole rock. There's a little bit of organic soil just underneath the sod here, but for the most part, This won't burn because it's made of pieces of rock. Of course, the extreme would be a desert situation, but what's going to burn there anyway? So, yeah. Around here, or most places, fire is an issue. The goal is to try to stop a fire. You expose this mineral soil at the soil surface and try to minimize the amount of organic soil that might potentially burn. Okay, so that's organic soil versus mineral soil. I think I alluded to previously that fire, typically, heat goes up. So fire doesn't oftentimes affect soil very deep, typically 1 to 2 inches deep. I remember doing a prescribed burn, and it was about 40 acres up at Cedar Creek. We lit it up, and some deer came. They didn't come flying out of the fire like Bambi, just wide-eyed and terrified. They were just kind of ambling out of the fire. They had an idea of what was happening, and they weren't going to get too excited. And then these two very large, dark-colored bull snakes came slithering out of that burn area, and pretty quickly disappeared down a hole. And they were adapted to insofar as they knew to get down a hole, they'd escape that fire. That whole, we're in a fire ecology here. The Cedar Creek area north of the cities, it's supposed to burn periodically, and the critters are used to that. Well, if it does burn, what kind of fire are we looking at? Well, typically we're looking at 2-dimensional versus 3-dimensional fire. Now, I will include right under this Firescience video lecture number 1 a link to a really awesome video of an area of Texas near Bastrop, Texas that's burning. And in the foreground, I can't show you that on this video lecture. It will block me because of copyright law. So I'm just going to put a link at this point in the lecture. Pause the lecture. Go look at the video. It's pretty cool. It's only a minute or a couple, 3 minutes long. But in the foreground, you will see a 2-dimensional fire. It's basically a grass fire. You don't have the vertical component to it. It's just a grass fire moving along. It's a pretty good rate. You can see the wind is blowing pretty hard, moving this fire. But honestly, if you look at the rate of spread of that fire, you could probably outrun it, at least for a while, if you didn't breathe in too much smoke. But it's still a pretty good fire. So the foreground is a 2-dimensional fire, grass fire. It does not have a vertical component. But in the background, you'll see a 3-dimensional fire, crown fire. You'll see it jump from one crown to another to another. That referenced in some of I think the Hinckley fire story, the crown fire, the danger of a crown fire. And so we would call that a 3-dimensional fire. And so, obviously that 3-dimensional fire is harder to fight. And that vertical dimension makes it much more dangerous, much more prone to be driven by the wind. And you saw that in the Oakland, California video, the effects of fire and how it could take those brands and just throw them a long distance, blow them a long distance, and spread that fire rapidly. Now, unfortunately for this whole lecture, there's a couple of demos that I would do in class, and I will do in class next Monday. But they won't be right along with the portion of the class that they would fit naturally with. But one of the lectures is good, or one of the demos, I'm going to take some ashes and show you what effect they have on the pH of soil. And then the other one, well, I'll mention that when we get to it just a little bit farther down the way here. Okay, so dimensionality of fire. Hopefully you've gone and looked at that Bastrop video that I've included a link to. Also on that video, then the next thing in your notes is rate of spread. And basically how fast is the fire moving? That Bastrop, Texas fire it's a pretty good fire. It's moving along pretty good. And I talked about how a fire manager would have to look at that. From a distance, figure out the rate of spread of that fire. How fast is that fire spreading? How fast is it moving? And then in my previous example, the fire manager would know how fast he or she could build a fire line and do a calculation to try to figure out how close to the fire could he or she build that fire line and stop the fire without losing too much ground. I will also have a video clip in class, if I can remember it, of somebody actual real time making that calculation. It's in an agricultural field, but it's pretty dramatic footage, and we can learn a lot from it. So that video coming too. So that's rate of spread. How fast is it moving? Another important point from that line, you see that fires burn faster uphill than they do downhill. And so if you think of a fire burning up a hill, that uphill portion, the ahead of the fire, the unburned fuel, is actually closer to the flame front than behind it. And so it pre-warms that fuel in front of it, and it ignites it more rapidly. Typically the fire's blowing brands that direction anyway. But then you get up to the top of a hill, and things slow down. And because the fire is going to burn more slowly down the other side of a hill. I'm going to pause the video for a second, pull up another image. Be right back. Okay, sorry about that. Yeah, I wanted to pull up this image. And here you can see, I'll probably have this up another day, but here's where a fire break has been constructed. And here the fire burned up this hill, burned this vegetation. This is probably some regrowth. But they were able to build a break here and stop the fire because they knew it would move more slowly. Yeah, you're going to have wind blowing firebrands up and over, but the rate of spread is going to slow down dramatically, and that gives you a fighting chance here to stop the fire before it jumps over the ridge. And so that's what they're looking at there. Here is a still of the image I alluded to earlier. A gentleman or a lady, I don't know who it is basically making a fire break. They're trying to turn over soil, mineral soil, and stop this fire from advancing. The fire is burning kind of that direction, and this tractor is trying to get around it. Now the calculus here is this tractor is moving through standing wheat field. So every bit of ground that this tractor turns over, that's yield that's lost. That's wheat that is lost. But he's trying to keep the fire from burning up the whole wheat field. And really the calculus is very real here. How much wheat does he have to sacrifice, or she have to sacrifice, to stop the fire and not lose the whole field? All right, where were we? Back here. So, rate of spread, faster uphill. Yeah, again, I'll have a video of that tractor doing the whole thing. Another thing that a fire manager is going to consider is the color of the smoke, and I showed you some of these images previously as well. But basically, if you look at, I don't know, I had an update done to this computer, and it totally screwed up all my Word documents, so I've had to reformat so much of it. If a fire manager looks at this fire, yeah, you can see flame down here, but this is a lot of white smoke, and that's going to indicate incomplete combustion. And the fire manager is going to not feel as pressed to devote, all resources immediately right to that. It's going to give him or her a little more time to marshal resources and figure out how to fight that fire. Same here. That white smoke indicates sort of a smoldering, slow-moving fire. Yeah, there's some darker areas in it. You want to pay attention to that. But again, it indicates a slower-moving fire. But contrast that with, whoops. Contrast that with the black smoke you see coming from this fire. Yeah, that's gonna be a lot more concerning, because that indicates that fire is burning much more rapidly, and it's going to scare people. And then the one that I showed you the other day, this one here, this fire, this is really ripping, and you can see those incredibly tall flame heights and black smoke billowing out of it. Yeah, there's white smoke there too. There's always going to be a combination, but that flame front is moving fast. It's eating up fuel as fast as it can. It's probably got a pretty good wind blowing it as well, and more scary situation. Okay, so that's color of smoke. That's something else that a fire manager is going to pay attention to. Generally, weather factors, that's the next item in your notes, are going to be something that a fire manager is going to pay a lot of attention to. Wind speed increases, we talked about that with Peshtigo and with Hinckley, that being the factor that really tipped the scales and created a major epic conflagration that killed so many people. There can be meteorological reasons for that. There are meteorological reasons for that, depending on advancing fronts and things of that sort. But then direction changes. If you are looking at a fire, and let's go back to this one here, and you can see the wind maybe is pushing that smoke a little bit this way, so you devote your resources to building a fire break on this side of the fire, try to stop it there, and then all of a sudden the wind switches and it comes out of this direction, and you've got nothing here, and you can't build it fast enough. So those wind direction changes can be a big deal. We used to burn a part of Bethel campus, and I remember one year out behind what's now the baseball field, we had just kind of 5-mile-an-hour winds out of the southwest, not a big deal, south-southwest winds. It was going along good. All of a sudden, and I mean all of a sudden, within a minute, that wind direction changed to the north-northwest. It ramped up to 15-plus miles an hour, and all of a sudden we had flame going from foot-high flames up to 10-foot-high flames, and my whole class, which was my fire crew, gave up their tools and ran for the baseball field. It was kind of an epic disaster. We got it stopped, didn't lose campus, but it was thrilling. So, sorry folks, I hit the wrong button there. Just did it again. Unfortunately, my screen, there we go, that's what I want. Okay, so right here, weather factor, wind speed increases, direction changes, dry lightning strikes. That's something I'm guessing people from Bethel, Minnesota aren't really as familiar with. But if you're from out west, something like this is much more common, and it can be a big deal. You can see what you think is a storm that you are sure is going to dump 2 inches of rain on you, and you run for cover and you don't get a drop. You got the cloud, you got the lightning, you don't have the rain. This is unfortunately all too common out west. But with that lightning, particularly if it's dry conditions, that can ignite a fire very readily. And we're going to learn that lightning strike is responsible for more acres burned in this country on an annual basis than any other cause of fire. And that's a good look at a dry lightning strike right there. Again, not common in Minnesota. Most of our lightning strikes are accompanied with an appropriate amount of rain, but not west of here. And then morning and evening suppress fire because you have lower temperatures and falling dew. So fire managers know that, and that's a chance for them to take a breath, if you will, to get out in those areas that have burned. And if there's fires smoldering in stumps or logs or anything that can hold a fire, they're going to get mop-up crews out there. That's what they're called. That could be a summer job for you, and try to get those fires out. Expose them to the air, and then put water on them and try to douse them, because they know the next day the dew is going to evaporate. The winds are going to pick up. Those stumps might kick off a spark, and the whole thing start all over again. That's the fear. So lower temps, falling dew, make evening and morning good times to fight fire. Adaptations to fire. We're going to go there next. I think I might stop this video right here and pick it up with the second video at that point in your notes. So some species are adapted to fire will be the next one. Thank you very much, and I'll have another video shortly.